So today we are going to discuss one of the also very interesting problems in data structure algorithms. So suppose if you have given this array and each array suppose represent the height of the building. So you can consider these are the buildings in your society and these are the heights given in the unit. And now you have to trap the rainwater. Suppose rain is happening from top, so you have to calculate how much water you can trap, and each building width is the 1 unit. Okay, so if you see here, nothing is there here, right? Its building started from here, so you cannot store any water here, because and this side also you cannot store any water. So you can store the water here, but how much height you can store the water? This much of height? No, it will not possible. So here and here, what is the minimum height of the adjacent building? That minimum height, up to that minimum height you can capture the water, you can trap the water. So in this case you can capture this much of, you can trap this much of the water, right? Only this much water you can take it. In this case, if you see, of course this much height must be you trap the water, but also if you see the height of this building and height of this building, this is the minimum height compared to this one, so you can trap the water this much also, right? So as I says that width is the 1, and you can say that height of the here 1, so you can trap the 1 unit of water here, right? But if you see here, this part, this is the 1 unit of water, this is the 1 unit of water, and here you can see we have the 2 unit of water. So you can trap the 2 unit of water. Now here possibility is here, right? So how much water we can trap? Of course not up to this height, we can only trap this much of the height of water, right? If you take so much of the height of the water, it will spill over, right? So here we can consume the 1 unit of water. And of course here we cannot trap the water because it will flow down. So in this case, if you see, we can consume, we can trap 1, 2, 2 to 4, 5 and 6. So output would be the 6. We can trap 6 unit of the water. So in the problem you will be getting one array, and according to this array you have to give the output how much water you can trap. So let me see some other example. So if you see in this example, so suppose if you have to find out how much water would be trapped here, right? So how you can know? So what I will do, I will check the minimum height of the adjacent left and right. So minimum of the left and right, and then minus what is the current building, which building I am considering height of that, right? If you see this one. So in this case, what is the minimum of the left and right? This is the 4, this is the 2, and height, this one is represent this one, right? How much height of this building? So minimum 4 and 2 is the 2 minus 1, so 1. So we can trap 1 unit of water. In this case, you see that left side building is more higher than the right side building. If you consider the same thing here, so in this case again we have to consider minimum between this left side building and the right side building. If you see 4 and 6, and you have to minus the height, the current building. So 4 and 6, of course this is the race, so of course we can have this much only water, right? We cannot have that water up to here, right? We have to only this much height of water. So minimum 4 minus 1 is equal to 3, so of course we can take the 3 unit of water. Here 1 unit of water, here 3 unit of water. So what you are doing here, actually you are taking the minimum of the adjacent left and right and minus the height of the current building. So this is the basic formula to solve this problem. If you see here, the both side is the same, even if you take the minimum of 2 and 2 and minus 1, so 2 minus 1, 1. So we can have this much of water. And suppose the height, and in this case, if you see here in this case, so what is the height here? Minimum 1, so 1 minus 0, right? So we can 1 minus 0 is equal to 1, so we have this much of the height. Because if you calculating the amount of trapping of water of this one, so you have to check the adjacent one, but it is not always. Suppose if you have the another building here, and you have another building here, and this height is the 3, this height is the 5, then amount of water would be the different. Then amount of water you can see here, amount of water you can see here, now you can consume up to here, right? This is much of water you can consume. So what is the formula here? So minimum of 3 and 5, minimum of 3 and 5 minus current height, right? So if you are considering only for this building, so 3 minus 5, 3 minimum 3 and 5, so 3. So you can have the 3 unit of water. So when you calculating you how much amount of trapping water, you only not depend upon the adjacent, you have to take the wrapped most height. So in this case I have already discussed you, if this building was not there, I was considering this height, but when another building is there, I was considering this one. So always you have to check what is the wrapped most highest building for that particular unit we are calculating, and the same case you have to find out what is the right most. So two things is important, one is the wrapped max height and another one is the right max height, that you have to always calculate. Okay, in this case if you see, we can't consume any water for this building, right? For this building, because there is no right side, so I cannot trap any water here. For this unit, I cannot trap any water, because left side we have the highest building, but right side we don't have the highest building, I can't trap this. But for, of course, for this we can trap, but for particular this building we can't trap, particular this building we can't trap. For this building, of course, right side nothing is there, but here the left side is there, but right side is not there. So both sides must have the building, is important, right? Okay, another case, see another case. In this case what will happen? So if you want to find out for this building how much trap the water, so you should not only depend upon the adjacent, you should go the wrapped most highest building. So this is the wrapped most highest building here, and right most highest, this is the 5. So minimum between the 2 and 5, of course 2, so this much of the water we can trap, if you considering the for this building, right? Again in this case, this is the 2 and this is the 5, of course 2, so we can have this much of the water, but for this building this much water is there. But in this case, this side also we have the opportunity to have the water. How much water here? Left is the 5, right is the 5, minimum is the 5, 5 minus 2, 3, so we can have this much of the water. So I have already given the basic idea. Now let me discuss what are the good approach to solve that problems. So the basic approach, that you maintain the two arrays. So one array is already there. You maintain the another array, that is the leftmost, and another array rightmost. For the each index you have to find out. For the 0 index, 2, 3, 4, 5. Here if you see, this is the index, right? Same way you have to create the same size of the two different array. One we have the left max, right max. For this particular index 0, you capture what is the left and right. So if you take the example for this 4, so for the 4 one, the leftmost is the 2 and rightmost is the 5, right? So what you have to do, you have to do the 3 calculation. Minimum of this 2 1 minus this one. So what I have to do, minimum of the left max I, comma, right max I minus height of the I. This much amount you can trap for the each building, and of course you have to do the sum, and this will run from the 1 to n and you will get the answer. But in this case, if you see, it will go to the space occupies too much, space complexity. You have to make this one, you have to this one, and of course you have to go for the n, and second time again you have to go the n. So much calculations is there, but I am going to explain one very good approach by which you can easily in one iteration you can find out the solution. So what you have to do for that? You have to maintain the two pointer. One is the left pointer and another is the right pointer. Left pointer we start from this side and right pointer we start from this side. Starting give the 0 and right pointer we start from the array 1. So array 1 is nothing, n minus 1, n is the your array length. Right. You can we can put that and make one while loop till L is not cross the R. So I will do one operation here and we will iterate both sides, right? The moment L and R is crossed, we understood that we have captured all those things. Now that's okay. Now the important thing, how we start this work. So as I said that you check that the building of the left side or the right side, which has the lower size of the building, you have to start from that side. So first in this case you have to check that if it is the height, check in this array what is the left pointer height. I am considering this is the L and this is the R. So check this comparison, this side of the building height compared to the height of the R size, right? If this is the vessel, I will start from here. So then I will give the one first condition here. How we can take the water? Suppose if you are taking the water for this one, this index, or suppose this index. So trapping the water, your left side building must be high. In this case, the left side building is the 0, so you cannot trap the water. So left side building must be high. If the left side building is the less, you cannot trap the water and you have to move forward. So that's why I am maintaining the two pointer. One is the left max and second is the right max. So left max you put starting the 0, whatever the value is here, means not 0, the height of the 0, first index, and rightmost index, the last index. So right now in left index is the 0, this 0, and rightmost is the 1. This is the value. Okay, you check that if left max is less than or equal with this height, current height. If this is the case, if your left index is less, we cannot take the water. So simply you have to update the left index with the height of the L. So now this time if you are here, of course the left index is also 0, right is also 0, so we are no need to do anything, we update the 0, but the next time it will update that. But if suppose this is not the case, your case in this case, if you consider this case, index is equal to 2. So in this case left index is more high, then what you have to do, if left index is more than high, to take one sum is equal to 0. In the sum we are going to add, what you are going to add here, height of the left max minus height of the current building, that much water you can save. Here in this case height is the 1, this height is 0, so 1 minus 0 we can that. So you have to do the left max minus height of the L. If it is done, then we can go and increment the left pointer. And the same thing we have to do for the right side also. Right side, what you have to do, you have to check whether the same thing, the right max, if this building, the right side is not the high, we cannot trap the water. So put the same condition whatever we have done the left side, instead of the left max we have to use the right max. But after that this L going to the increase, but R would be going to the decrease. And that is the good solution what I've understood, and let me see in the code how it works. Okay, so if you want to do the dry run here, so you can just keep it dry run and you will consider how. So suppose now first time this R is 0, this is also 0, right max is the 1, so this condition is true because R is the 1 and the right is the 11, right? What is here? This is the 11. So this condition is okay. We will come here, wrapped max is 0, and what is the height of the L1? This is also 0. It is not going to work. So then this is so wrapped max is equal to 0, height is also 0, condition is true. So in the wrapped max I will put the 0. So anyhow wrapped max is already 0. Then we have to wrapped max is equal to 0 right now, right? And then you have to L plus plus. Now this L will be come here. Next time if you see that L value, this one is still, this is the 1 and this is the 1, right? So still it is not working, or you can put the equal, no problem. So now you can consider here, this time this is the 1 and the wrapped max is equal to 0. So this condition is going to satisfy. So this time wrapped max become the 1. And when it will come the next time, it will run this one and our answer will be get it. I will be seeing the code and you will get the more clear. Thank you. As we discussed that, wait some input variable, first we will do the sum 0, and before that also n is equal to how much height, so how much index, how much number of arrays you should take it in n, and then as I discussed, use the wrapped max. That wrapped max would be the first element of the array. So of course height of the first element, and in right max we have the height of the last element, right? Last means n minus 1 element, and take the two pointer. One is the wrapped pointer. Wrapped pointer would be on the 0, and the right pointer would be on the last one, right? N minus 1. So last index. This is both are the these two are the index, and these two are the value of that index, right? Let us start our logic here. So we check while wrapped pointer should be less than the right pointer. So in this case we should be able to cover from the left to right, but for all the index. First and foremost, check if height of the left side is less or equal, as we discussed, compared to height of right side, right pointer. If the left side pointer is less, then we can start from the left side. So now we came to the left side. What I have to check? We have to check that whether the max value must be greater than the current building height. Otherwise, I will not take the water. If that is not case, we have to update about the left max. So if left max is less than or equal of the height of the left pointer, then we cannot do anything. Only we have to update the left max, right? So next time we consider that. If that is not the case, so suppose left building height is more than the current building, so what I will do, in sum we will take the difference between the left max height and the current building height, right? So left max height minus this one, and of course the left pointer, if we do all those things, then it should be increment. Now else part means that height of the right side pointer, means right side pointer is the more height than the left side building, so we will start from the right side and again check if right max is smaller or less than the height of the right pointer. In this case, if that is the building is not much height, we cannot store the water, so update the right max, and then if it is not the case, then we can take the water and check what is the difference between that. So write max minus the current building, this is the current building, and then of course right pointer we have to decrease, right, as we discussed that. I think that's enough. So now here, come here and return the sum. Let me check whether this code works or not, and then we will submit the code. Okay, so it is saying that what is the, oh, so we, it is, if, okay, some problem is there, so it should be the else here, right? If part should be done here, then else part should be here, while should be here, then this is the extra one, right? Then of course everything should work, right? Yeah, it's working fine. Let me submit this code and see. Yeah, it works. 1 millisecond taken, and good performance here. Thank you very much. Please don't forget to support this channel after subscribing to the channel, and likes, comment something for betterness for this channel. Thank you.